Yes, it's MK the guy. Today let's talk about quinolones as a class of antimicrobial. Please don't forget to subscribe, like the video, and share to all those whom this video may be helpful. We are going to introduce our quinolones, talk about the general structure, classification where we have the isosteric, heterocyclic grouping, and generations. We talk about the nitric acid and why was it limited to UTIs. We talk about the SAR specific agents. These are other quinolones and fluoroquinolones. We talk about the chelation, pKa, and crystallization. We talk about the mechanism of action and why is it that these quinolones are not effective or do not treat syphilis, resistance, indications, ADR, drug interactions, and contraindications. We talk about the nomenclature. Yes, let's introduce the quinolones. First, these quinolones are bactericidal. They are bactericidal antimicrobes. They inhibit the activity of the DNA gyrase. And topoisomerase 4. We are going to see this mechanism here. Also, they are present as a topic as oral, parenteral, and ophthalmic use. These quinolones, the earlier ones, they had a narrow spectrum. The newer ones have a wider spectrum. The earlier ones were restricted or they are limited on inhibiting the gram negatives, while these new ones, some can act on the anaerobes, the gram positives, and many other microbes, as we are going to see here when we are talking about the nitric acid, because it's one of the earlier quinolone. Then we talk about the specific agents here for the new quinolone. About the genome structure, they all have this ring, which is the N1 alkylated 3 carboxy. Pyride 4 on moiety or ring. They all have this ring where the X represents the alkyl group. It can be the ethyl group, can be the cyclopropane or other alkyl groups. So this is they all have this ring. Then the pharmacophore is 1,4-dihydro. It is 1,4. This carbon and this nitrogen, they are saturated. So it is 1,4-dihydro. Then at position 4 we have oxo. Then 3 3 pyridine carboxylic acid. So this is the pharmacophore. This group without the X is the pharmacophore. Though this ring, to do whatever it does, it should be attached to an aromatic ring. An aromatic ring. This ring can be benzene ring, can be another pyridine ring. So these positions, all the carbons can be nitrogens. For example, this one can be N, but let's use this. So it should be attached to an aromatic ring. And this aromatic ring also has substrates. So we can have, this is, can be R5, R6, R7, this is R8. Those are groups which can be modified or changed. So this is the position 1, this is 2, 3, 4, 5, 6, 7, and 8. So this is the digital structure for all the quinolones. The pharmacophore is this one, the pharmacophore, which is responsible for the binding to the DNA to inhibit the activity of the DNA gyrase and the topoisomerase 4. Now, let's talk about the classification. Yes, about the classification, we said we can group them or we can classify them according to the heterocyclic rings and generations. So about the isoheterocyclic ring, the isoheterocyclic ring grouping, we can have the naphthalidins. We can have the naphthalidins. We said this one is an alkyl group. So we can have the quinolones, which have this ring. We are going to see them. We can have the quinolones. We can have the quinolones, which have this quinoline, or quinolone, which have this quinolone ring. We can have the sinolines. So these three rings. Now this one is, it is 1, 8 naphthalidine. Naphthalidine ring at position 1 and position 8. But we may have 1, 6 here and here. So this carbon can be changed to nitrogen. Then this is the quinolone ring, and this is the sinoline, or the sinolines, the quinolones, and the naphthalidins. In naphthalidins, we have the nidixic acid. Here we have the gemifloxacin. We have the tosfloxacin. We have the trovafloxacin. We have the enoxacin. among others. In synonyms we have the synoxacin. In synonyms, then in quinolones we have many of them, the ciprofloxacin, the levofloxacin, ofloxacin, among others. There are very many. You can classify them by this grouping, or we can classify them as the first generation, second, third, fourth, or classification by generation. We have the first generation, we have the second, we have the third, and the fourth. In the first generation, these microbials, the quinolones, had narrow spectrum. They are restricted on the gram negatives. They were highly protein binding. They had low tissue permeability. And they had low activity on gram negatives like the Pseudomonas aeruginosa. So activity on Pseudomonas aeruginosa was very poor. They were highly concentrated in urine. They had high urine concentration. The first generation had no activity on anaerobes. They had a short half-life and were highly metabolized. In second generation, the spectrum was improved. So they had a wider spectrum. These ones were also effective on the gram positives, some gram positives. The tissue permeability was improved. Though the activity on anaerobes was not yet improved, so they have no activity on anaerobes. The protein binding reduced, so reduced protein binding. Half-life was improved. For the third generation, the permeability was improved compared to this one. So they have higher tissue permeability compared to the second generation. So we are going to see all these at SAR. We see which groups were added the third generation, which groups are there on the second generation, and which groups are in first generation. Then also in second generation, the activity against Pseudomonas aeruginosa. This one had poor activity, but here in second generation, activity was increased. So they have activity against these Pseudomonas. Aeruginosa. Wider spectrum gram positives. So the gram negative activity was retained. Also in gram negatives. Here, there is higher tissue permeability and improved activity on gram positives. But activity against Pseudomonas aeruginosa reduced due to increased activity on the gram positives, the groups which were added. So activity against Pseudomonas aeruginosa reduced. But they are not yet active against anaerobes. So activity against anaerobes is not yet much as in the fourth generation. So it is very low activity. Activity is very low. In fourth generation, these have the widest spectrum. So they can act on the gram positives, gram negatives, and also anaerobes in the fourth generation. So we are going to see all these ones, why they are active against anaerobes here at SAR and the specific agents. Now, let's talk about the nadixic acid and why was it limited to UTI